Hi, welcome. This is Clemens at Elector. In this video I will show you how to get started with the ESP32 microcontroller from Shanghai-based company Espressif. Over the last few years the ESP32 has become a very popular microcontroller amongst makers and electronics hobbyists, but also in the industry. There are several reasons for this. It has built-in Wi-Fi and Bluetooth. It is incredibly powerful. It is cheap, as unit prices for a single core version start at around 1.5 euros and dual core versions cost about 3 euros. There are many low-cost development boards available, and there is plenty of good documentation. Good documentation is important, and Espressif has made a huge effort to make the ESP32 accessible to makers as well as professional users. Besides good documentation, Espressif also provides development tools like the compiler and libraries for free. The ESP32 is probably the first and maybe the only microcontroller that was launched with support for Arduino. The wireless capabilities of the ESP32 are what its users will mention first, but it has much more than that. The device comes with many peripherals like a SPI, I2C, UART, but also CAN, which is called TWAI, which stands for Two-Wire Automotive Interface. It has a LED and motor control support, a PWM, I2S for audio, analog in and outputs, infrared remote control, timers and counters, Ethernet, SDIO for memory cards, a touch sensing support, and it even has a built-in Hall magnetic field sensor. Even though this long list is incomplete, there are two things the ESP32 does not have. First of all, it does not have a USB, and secondly, it does not have a flash memory. Well, this is not entirely true. There are versions that have built-in flash, but most don't. Most ESP32 based boards and modules have external flash memory, even though it may be built into the chip. Confusing? Just don't worry about it and remember that most ESP32 boards have 4 MB of flash memory. At the heart of the ESP32 are one or two Xtensa LX6 32-bit processor cores clocked at up to 240 MHz. The ESP32 started out as a dual-core device, but today single-core versions exist too. Actually, the ESP32 has one more processor core, which is intended for low-power operation. It will be clear by now that the ESP32 is a versatile device that can be used in a wide variety of applications. The Internet of Things is, of course, one of them, and this is accentuated by support for popular cloud service providers. Apart from cloud support, Espressif has tons of repositories on GitHub with example code and demo applications. Besides the libraries from Espressif, ESP32 users have published lots of code too, making it quick and easy to get an application up and running. At Electro we have the book The Complete ESP32 Project Guide, written by Dogan Ibrahim, and which is full of fun projects. There is also the Elector ESP32 SmartKit bundle that contains this book, together with a kit of parts, which includes an ESP32 module. So this is great to get started. But before you can start creating your own applications, you must install a development system or a toolchain. There are several options, but here we will limit ourselves to MicroPython, AT commands, Arduino and ESP-IDF, and in that order. MicroPython is a stripped-down version of Python that runs on microcontrollers. With MicroPython, you can program the ESP32 in Python. As many people already know Python, this is quite practical. The ESP32 does all the Python stuff itself, so no other tools or programs are needed. The only thing you must do is program the ESP32 with the MicroPython firmware, and this can be done with Python. For this you need, of course, Python, but you probably already have that installed since you are interested in Python. If not, install it first. Then you must install ESPTool, the tool to load a program in the flash memory of the ESP32 board. Download the MicroPython version suitable for your ESP32 board from the MicroPython website. To be sure, first erase the ESP32 and then program the firmware. After programming, launch a serial terminal to bring up the REPL prompt. Type help to see if things work. If they do, you are all set for ESP32 application development with MicroPython. AT commands date back to the 1980s. They consist of short text-based commands beginning with AT sent over a serial link to a target where they are executed. The target used to be a modem, and the commands let you control the modem and send and receive data. Espressif has developed an extended AT command interpreter called ESP-AT that allows controlling the ESP32 over a serial port by, for instance, an Arduino or another microcontroller that you already master. This is nice as it lets you use the ESP32 without having to program it at all. Setting up ESP-AT can be done with ESPtool in the same way as MicroPython, except that you must specify the ESP-AT bin file instead that you downloaded from the Espressif website. However, for those who do not know anything about Python, we will now use the ESP Flash download tool instead of ESPtool. This tool exists only for Windows and can be found at the Espressif website. As a matter of fact, you can use this tool also for programming the MicroPython firmware. Launch the program, click Developer Mode and then ESP32 Download tool. Locate the ESP-AT bin file, which is inside the factory folder of the download. Enter 0 in the address field and do not forget to check the box in front. Make sure that Do Not Change Bin is checked too. Select the COM port and set the speed to something fast. Finally, click the Start button and wait until programming is finished. ESP-AT uses a second serial port for the AT commands. To try it with a computer, you need a serial to USB converter and open a second serial terminal to enter the AT commands and see the responses. Make sure to terminate commands with a return and a line feed, CR plus LF. Now you can use the ESP32 as a Wi-Fi or Bluetooth add-on for another microcontroller. A third way to work with the ESP32 is with the Arduino IDE. This gives you access to the huge collection of libraries and applications developed for Arduino. Basically, it turns the ESP32 into an Arduino board with Wi-Fi and Bluetooth, simplifying application development quite a lot. Note that the ESP32 Arduino core can also be used with, for instance, Platform I/O. Setting up the Arduino IDE for ESP32 is easy. It starts by adding a repository to the boards manager of the Arduino IDE. You do that in the IDE's Preferences window. Then open the boards manager, search for the ESP32 package and install it. You now can choose an ESP32 board from the boards menu. As there are many possibilities, chances are that your board is listed here. If it isn't, don't worry, just choose the first entry and then customize it from the Tools menu. The default values will work in most cases. You can now try out the examples or write your own program like I did to blink an LED with the ESP32 Pico board. The most advanced way for ESP32 application development is ESP-IDF. This gives you full control over everything, but it's also the most complicated. Luckily, installing it is easy, especially on Windows, as a nice installer package is available. Application development is done in a Bash terminal or command prompt window, but an Eclipse plugin is available too. A project is built in a few steps. After creating a project folder, you must set the target chip and configure the project with the menu config tool. Then build it, which takes a while the first time, and upload the executable to the board. If you specify the monitor option, a serial terminal will open that displays program status. We will stop here. Summarizing, I have shown you 4 ways to get started with the ESP32 microcontroller from Espressif. From simple AT commands and MicroPython to Arduino and C++ programming with the full-fledged ESP-IDF environment. If you want to go further, we have the book The Complete ESP32 Projects Guide, written by Dogan Ibrahim, which is full of projects for Arduino, MicroPython and ESP-IDF. There is also the ESP32 SmartKit bundle that contains this book, together with a kit of parts, including an ESP32 DevKit-C v4 module. Okay, that's it. I hope you found it interesting. Please don't forget to subscribe to our channel and click or tap the bell button. Thank you for watching.